Centrifugal pump tutorial question number 7. A centrifugal pump with the R2 equals 63.5 millimeters, B2 equals 10.16 millimeters, beta 2 equals 60 degrees, is pumping kerosene with specific gravity of 0.80 at a rate of 7.57 liter per second and rotating at 2000 rpm. For the best design entry condition, determine the theoretical pressure, head rise, and fluid power. Best design means there is no whirl velocity at the inlet. So I hope you know how to draw the velocity triangle with whirl velocity equal to 0 at inlet. And then in this calculation, you must use density 800 kilogram per meter cube because the specific gravity here is equal to 0.80. First, you need to draw the velocity triangle. So this is the velocity triangle that you should draw. There are no whirl velocity 1 at inlet here. The angle is 60 degree here. The theoretical pressure rise is equal to Euler head. So to calculate this one, you should know what is the equation for Euler head. So this is the equation for Euler head after we neglect the value of V1. To calculate this one, we need to know the value of V2 and U2. The value of U2 here can be calculated by using this equation. We substitute all the value, we could get U2 equal 13.3 meter per second. And then to calculate V2 here, we could use this equation. And to solve this equation, we should know the value of VF2. And VF2 can be calculated by using this equation. And we get it is equal to 1.8672 meter per second. Then, by having this equation, by having this value, we could get V2 is equal to 12.222 meter per second. Then we substitute in this equation, we could get Euler head is equal 16.57 meters. To calculate the power output, we could use equation of rho GQHE, and it is equal to 984 watt.